Okay, get ready for the greatness of synthetic division. This is a shortcut way of doing long division, and it's so painless and effortless, and everybody loves it. The only thing I need to warn you about is you cannot use it every single time you have a long division problem. You have to be really careful. Synthetic division you can only use if you are dividing by a linear factor. Now, what does that mean? Linear, you know, linear means line. It pretty much just means this needs to have an exponent of 1. So as long as you have x to the first plus or minus a number, you're good to go, and you can use synthetic division. But if there was like a x squared or x to the third, unfortunately, you must go back to long division for that. But for this one, here, let's do the shortcut version. So what I'm going to do first is I'm going to go ahead and rewrite it as a long division problem, because I want you to see me filling in placeholders. In other words, remember that the exponents need to all be accounted for, and I notice on this one that I am missing my x term up here. See that? It jumps from an x squared to a constant, so I need to fill that in. Now, you could roll into long division right here, or we could do synthetic. And with synthetic division, all you need to do is flip this division sign upside down and copy down these coefficients. Okay, so 3, -1, 1, 0, and -10. Notice I did not take the x's with it, and notice I took the negatives with it. So be really careful. If you see minus sign, you better bring that down with it. And now I need to know what to divide by. So this is the only part people forget a lot. If I'm dividing by an x plus 2, I'm actually going to use -2 as my divisor. The way you could think about that is we're taking out a factor of x plus 2, but kind of like you learn in class, if you set that factor equal to 0 and move the 2 to the other side, it's really a -2. So this is what we need to be careful with. X plus 2 means I'm dividing by -2. Now with synthetic division, it's only 3 steps and then you repeat. So the first step is to bring below the line whatever this first term is. Okay, so the first coefficient, just drop it below the line. No math has been done. Now anything below the line is going to get multiplied. Anything above the line is going to get added. Okay, so if I have something below, I need to look out to the very front, and I'm always going to be using this -2 with all of my numbers down here. So I'm going to start by saying -2 times 3 is -6. That's going to go in the next available spot in my diagram. So you're eventually going to have all these spots filled up, and we just keep repeating the process. Now I have 2 numbers above the line, and my note to self says that anything above the line gets added. So a -1 and a -6 added makes a -7. Now we repeat. Okay, go back to the front, look at what's here, and multiply by what's on the bottom. So -2 times -7, +14. Anything above the line gets added. Back to multiplying, adding, and then the last step, multiply again. -2 times -30, that would be what, 60, and then add those. All right, cool. So when you have all the numbers in place, right now it means nothing to you, but you actually just found your answer, the same answer you would have found up here if you had done long division. The only thing missing is x's. Now when you get to the very back number, this is always your remainder. And so the way that it works is these are your new coefficients, and they all need an x behind them. And the way that you know what x to start with is to subtract 1 from the original problem. So in other words, this 3 was originally 3x to the 4th. Well, now that I've taken a factor out, it becomes a 3x to the 3rd. So this will always be 1 less than what you started with right here, okay? And then we just count down. So like I copied the 3, now I'm going to bring down this -7, and it'll have an x squared. I'm going to bring down this +15, and it'll have an x, and then I'll bring down the -30. Now I'm out of x's, so it's just a constant. The only thing left is to deal with the remainder, and you may remember from the long division series that you just need to take that 50 and put it over the original divisor, which is right here. And this is the same thing that you would have gotten had you gone through all of the long division before. So I'll do one more very quickly in case you were just absorbing on that first one. So let's pretend that we were dividing like 4x to the 6th minus x to the 5th plus 3x cubed minus x plus 6 divided by x minus 1. Okay, so the first thing I'm going to do is draw my upside down synthetic division symbol. In fact, I'll switch colors here. Okay. And I need coefficients, okay? So make sure as you do your coefficients, if anything's missing, fill in a 0. So it's going to be a 4, a -1. Now look, I'm missing x to the 4th, so I need a 0. 3, I'm missing an x squared, so I need a 0. So I'm copying down all the coefficients and filling in the ones that are missing with a 0. Now there's an x minus 1 on the bottom, which means that a positive 1 is going in the front. And now I start the process. Bring down the first coefficient, and I start my multiplying. 1 times 4 goes here. Anything above the line gets added, so that would be a 3. Back to multiply, add, multiply, add, multiply, add. It's getting redundant. Multiply, add, multiply, add. So it goes very quickly once you get good at it, okay? Now the last number is the remainder. I'm going to go ahead and box that off. And now I just need my x's. So my answer is going to be 4x to the what? What did this start as? It started as x to the 6th, so now it's x to the 5th, plus 3x to the 4th, plus 3x to the 3rd, plus 6x squared, plus 6x, plus 5. Now I need my remainder over my divisor. So hopefully that helps. I love synthetic division. Just remember, you can only do it if this has a exponent of 1 in the denominator. All right, good luck.